Assalamualaikum. Hi everyone. So this is the video for the second part of 1.3. In this video, we're going to look on state our Heinous equation, explain the relationship between temperature and activation energy to the rate constant based on our Heinous equation, and determine K, EA, T and A using calculation and graph method. So let's start. So our Heinous equation, what you need to know for our Heinous equation? So this is the equation for our Heinous equation, and what do we have here? So K is our rate constant, R is universal gas constant, and the value for our universal gas constant here, we will use 8.314 joule per mole per Kelvin. So make sure you choose the correct R value, the correct gas constant. Okay, and then E, base of natural logarithm, T, our absolute temperature in Kelvin, and EA, our activation energy over here, and A, our frequency factor. Okay, so this is one form of your Arrhenius equation. So if we want to remove the E here, what we can do is we put ln on our equation. Okay, ln, and the equation that we will get will be ln K equals to ln A minus EA over RT. So this will be our equation. Okay. So now, what can we get from this Arrhenius equation? Okay. So from the Arrhenius equation, at higher temperature, what we'll get is you will get a larger K. Okay. When you have a larger value of rate constant, this will show that the reaction rate will increase, meaning the temperature will affect the rate by affecting the rate constant. Okay, as we increase the temperature, it will affect the rate, it will affect the rate constant, and it will affect our rate of reaction. Okay, so you need to make sure that you memorize these two equations. So we have two equations here. Okay, this one, the initial Arrhenius equation, and then here the second one. Okay, so now we're going to look on how are we going to use this Arrhenius equation in answering the question. So the question can ask to determine K, EA, T, and also A by using Arrhenius equation. Okay, actually we will have two methods or two different types of question. Okay, one is by calculation, the other one is by using graph. So we're going to look on the question based on calculation first. So for question involving our Arrhenius equation that we're going to solve by using calculation, there will be two more types of question. Okay, the first one, when given one data, only one data, meaning from here, okay, you only given 1K or you only given one temperature. So that what I meant by one data. So this will be the equation that we will use. Okay, so let's take a look on the example question. So example 1. The decomposition of N2O5 has an activation energy of 103 kJ and a frequency factor of 4.3 times 10 to the power of 13 per second. What is the rate constant for this decomposition at 100 degrees Celsius? Okay, now, so like I mentioned before, we have two types of calculation question, where first we have one data, the second we have two data question. So how to differentiate this one data and two data question? Okay, so let's highlight the information that we have. First, I have activation energy, and then I have frequency factor. Okay, after that, the question gives you temperature of 100 degrees Celsius. So this is our EA, this is our A, and this is our temperature. To identify either it is one data question or two data question, look on the information on temperature or the information on the rate constant. Okay, so if given to you only one temperature or one rate constant, meaning the equation that you will use is just the general Arrhenius equation, which is you can use K equals to A exponent to the power of EA over RT, or you will use ln K equals to ln A minus EA over RT. Okay, so now let's solve this problem. So this is our question just now, and the information that we take out from the highlighted question here. Okay, so as we have decided just now, we will solve this question by using just the general equation of Arrhenius, okay, which is K equals to A exponent to the power of EA over RT. Okay, so before we put all the information into the Arrhenius equation, let's check again our information. So the first thing, for the activation energy, you need to make sure that the value is in joule per mole. Okay, why do we need the value of activation energy in joule per mole? Because our R, our gas constant, the value of our gas constant will be 8.314, and the unit is joule per mole per Kelvin. So that's why you need to make sure that the value of EA over here must be in joule per mole. Okay, so let me write that back. So here, the value that we will substitute into the equation will be 103 times 10 to the power of 3 joule per mole. So that's the first one. Next, okay, A, we have no problem with A. And then the value of T. Okay, so since from our gas constant here, the unit is Kelvin, so we need to make sure that our temperature is an absolute temperature, which use the unit Kelvin. Okay, so we need to change 100 degrees Celsius to Kelvin, okay, by adding 273.15. So we will get the temperature as 373.15 Kelvin. Once you have all the information in the correct unit, then you can substitute into the equation. We want to find what is the rate constant K. So now substitute. So we already have the value of A. So A is 4.3 times 10 to the power of 13. Okay, and then exponent. So you need to make sure that the negative, okay, put the negative sign and then put the bracket here. Okay, meaning the negative sign is actually for all. Okay, so our activation energy 103 times 10 to the power of 3 over, okay, our R, okay, 8.314, okay, times our temperature 373.15. Okay, so just substitute correctly like this. Okay, and then you need to make sure that the way you write it is very clear. Very clear here means everything we have here, EA over RT, is exponent to this. It's the power of this. Okay, so you need to make sure that the examiner can see it clearly. Okay, so find the answer, use your calculator, and then the rate constant will be 0.16 per second. So this will be the answer for example 1. So the next one, by using calculation, if the question gives you two sets of data, so two data given, so know the rate constant at two different temperature. Okay, what do I mean by this? When you have two sets of data, it's either you have the question give you two value of rate constants or two values of temperature. So this is the equation that you will use. So now let's take a look at the question, the example question, when we're going to use this equation. So example 2. The decomposition of Hi has rate constant. So two rate constants given with two different temperatures. So what is the activation energy of this reaction in kilojoule per mole? So clearly you can see here the information that we have. We have K, we have K, two value of K and two value of temperature, okay, given here. So what you can do is label. Okay, so let's say I want to put this one as K1. So 508 here will be temperature 1. Okay, and then this is K2. So 540 here will be temperature 2. So now let's take a look on how to solve this question. So this is the information that we have just now. So I just write it back here. So our K1, T1, K2 and T2. And the equation that we have decided to use is ln K2 over K1 equals to negative EA over R 1 over T2 minus 1 over T1. Okay, so which one should be K2, which one should be K1? It's up to you. Actually, the 0.24, you can put it as K1, but 540 will be T1. You just need to make sure that the pair is the same. That's it. Which one is the first and which one is the second, it doesn't matter. Okay, just need to make sure that you use a correct equation over here. So before we put all our value into the equation, so you need to make sure that the temperature must always be absolute temperature, meaning it should be in Kelvin. Okay, so change the temperature in Kelvin. So plus 273.15. So here you will get the temperature, okay, as 781.15 Kelvin, and temperature 2 plus 273.15. So we will get the temperature as 813.15 Kelvin. So once you have your temperature in Kelvin, so change the temperature into Kelvin, then you can substitute into the equation. So ln, so you need to make sure the ln, put a bracket over here. It's not ln K2 over K1. The ln is not only for K2, but it's for the whole expression K2 over K1. So please pay attention here, because that is a common mistake that students usually do. Okay, so let's continue. So our value of K2, 0.24 over 0.079 for our K1 equals minus, so don't forget the minus sign, so EA, the one that we want to find, and then R, we are still using the same R, which is 8.314, and then 1 over our temperature that we already changed into Kelvin, 813.15 minus 1 over 781.15 Kelvin. Okay, so make sure you rearrange the equation and then find what is the value of EA. So from calculation, the value of activation energy that you will get is 183,380, and the unit that you will get here is joule per mole. Why do we get joule per mole? Okay, again, it's from our gas constant R equals to 8.314, and the unit of R is joule per mole per Kelvin. Okay. So the Kelvin part is already removed from the temperature term. Okay, you need to make sure that it's in Kelvin. So for the activation energy, the unit will be joule per mole. Okay, this is from the calculation, but you need to remember for activation energy, the unit must always be in kilojoule per mole. So what you will do, divide by 1000. Okay, so you will get the activation energy is 183. Okay, pardon me. So 183.38 kilojoule per mole. So if you just leave your answer up until here, you still don't get the final mark. Your final mark, you will only get when you change it in kilojoule per mole, because the question already asked for kilojoule per mole. Okay, but if the question didn't ask for kilojoule per mole, so should you write joule or should you write kilojoule? So since it's activation energy, so put it as kilojoule per mole, unless it's stated otherwise. Unless the question insists, write down the answer in joule per mole. So you will write down in joule per mole. Now, let's take a look on the question that used graphical method. So, when I say graphical method, meaning you need to plot a graph to answer this question. Okay, so by graphical method, so we will use this equation. Okay, the equation over here, the ln K equals to negative EA over R 1 over T plus ln A. Okay, so this is actually rearrangement from our equation just now. So just now, the equation that we have is ln K. Ln K equals to ln A, okay, minus EA over RT. So to put it into graph, so we must have our y-axis and our x-axis. So that's why we rearrange the equation so that our y-axis will be ln K, okay, and our x-axis will be the information on 1 over temperature. The intercept is ln A and the gradient will be negative EA over R. So when you plot the graph, this will be the graph that you will get. Okay, you will get a linear graph which the gradient is negative. So you need to make sure that your graph at the y-axis ln K, x-axis 1 over T with the unit per Kelvin. Unit must be stated here. For ln K, there will be no unit since we put ln. Okay, but for 1 over temperature, there will be unit per Kelvin. Okay, so this is the information that I tell you just now. Y-axis, ln K, x-axis 1 over T, so the gradient is negative EA over R. And the value of C, the intercept at the y-axis, is ln A. Now, let's take a look on an example question. So example number 3, the rate constant for reaction 2D to produce G are obtained at 5 different temperatures. So you have 5 temperature here, and then you have the value of K. So based on the data from the experiment, plot a suitable graph and determine the following. So the question asks you to find the activation energy, and the second one to find the frequency factor. Okay, so the first thing that you need to do is, you need to plot a graph of ln K against 1 over T. So you need to change the data you have here. The one that we have is in temperature and Kelvin, but the one, temperature and K, rate constant. But the one that we're going to plot is 1 over temperature and ln K. So make another table to find the value of ln K and the value of 1 over temperature. So this is our question just now, and what you can see that I have done here, I already find what's the value of ln K and what's the value of 1 over T. Okay, and then for the unit for 1 over T, I put it as 10 to the power of negative 3, K negative 1. So why do I put it like this? So that it will be easier for me when I want to plot my value over here, my scale. But you need to make sure that at the unit, it needs to be 10 to the power of negative 3. And once you want to use it for the calculation, you need to make sure that you include 10 to the power of negative 3. Okay, so this is the graph. So it's not necessarily you need to start from 0. So if you don't start from 0, so you need to have this squiggle line. Okay, I'm not sure what's the name of this, but you can put it as this. So it's not necessarily must start from 0. Okay, so I have plotted my graph. So the first one, I want to find activation energy for the reaction. So as we know, since we have our graph over here, to find the activation energy, we will use the gradient. Okay, because from the one that we have done just now, okay, y equals to mx plus c, y is our ln K. So the gradient is negative EA over R. Our x is 1 over T, and our c is ln A. So from here, to find the value of activation energy, you need to find what is the value of the gradient. Okay, so you need to show on your graph where you want to take your gradient. So let's say here I take two values, so 1.23 with negative 0.25 and 1.41 with negative 4.25. So write down back. So over here, from the gradient, okay, so or you can just put from the graph. Okay, so from the graph, so your gradient, so negative 0.25 minus negative 4.25. So this is our y-axis, and then the x-axis, so 1.23, and take note that you have the 10 to the power of negative 3. You must include the 10 to the power of negative 3. Okay, minus 1.41 times 10 to the power of negative 3. Okay, so this will equals to the value of negative EA, the one that we want to find, and our gas constant, 8.314. So from here, rearrange and calculate. So we will get our activation energy. Okay, our activation energy as 184,755, and the unit is in joule per mole. So activation energy, it must be in kilojoule per mole. So change it, divide by 1000. So 184.76 kilojoule per mole. So that will be the answer for question number. For question A. Okay, now for question B. So by right, for us to find the value of A, we need to find the intercept of our graph to find the frequency factor A. Our intercept, our C here is ln A. Okay, but the thing here is, you need to, if you want to find the interception, you need to start with 0 from here. Okay, so since I did not start from 0, okay, for this question only, for this example, you can use the equation, okay, the Heinous equation. Okay, now, so let's calculate for question B. So for question B, we want to find the value of A, so let's use the Arrhenius equation. So K equals to AE, A exponent to the power of EA over RT. Okay, so for this one, choose any value of K and temperature from your question. Okay, what I meant by this is choose the pair, meaning let's say I want to choose the temperature as 700 Kelvin. So the value of K that I will use is 0.011. Okay, so use that, substitute in our equation. Okay, so 0.011 equals to, we want to find the value of A, so exponent, the activation energy that we get just now, so make sure that the activation energy is in joule per mole. Okay, so joule per mole, so 184.76 times, okay, in case you can't see it clearly, 0.76 times 10 to the power of 3 joule per mole over the R 8.314 times the temperature, which we take as 700 Kelvin. Okay, so we will find and get the value of A, okay, as 6.74 times 10 to the power of 11, and the unit is per second. Okay, now, so how do I get the unit for A as per second? It came from our rate constant. So the unit for our rate constant K is per second. Okay. So that will be the end of this lesson for 1.3 and also the end for chapter 1. So with that, you can start to prepare for your quiz, for your topical quiz that I will tell you soon when we're going to do it. Okay, so that's all. Thank you for listening. Thank you for watching. Thank you guys.